So what we're going to do is we're going to apply the Pythagorean theorem in order to find a distance between 2 points on a coordinate plane. The first thing that we actually have to talk about is the word distance, because distance means something very specific in math, okay? What I want you to think about is the distance between 5 and 3. The distance between 5 and 3 is going to be 2. Okay? If you think about a number line, here's your 5, here's your 4, here's your 3. The distance between them is 2. Now, how do you get that 2? Well, you could do it by drawing a number line and counting. But if we're talking about like a mathematical operation, you could also think of it as subtracting. 5 minus 3 is 2. So a lot of times what kids will do is when they're asked to find the distance between things, they use subtraction to find it. However, there is a little bit of a problem with that sometimes. What if I asked you to find the distance between -13 and 4? Here's where some of the misunderstanding kind of comes in. Because I'm asking for the distance, they assume that that's subtraction again, just like up above. Now, if I really subtracted that, I would get -17, technically, right? But distance can't be negative. Remember that when we learned about absolute values are distances. There's no such thing as a negative distance. Like you can't pull out a meter stick and look at the numbers and find negative numbers on it. Or if you drive your car around the block backwards, the numbers don't go backwards for how far you went. They're not negative. It's not a negative mile that you drove. Okay? So -17 as a distance doesn't make sense. So subtracting doesn't really make sense in this case either. However, if you think about it on a number line and you're thinking about the distance between them, here would be 13 and here would be 4 more. The distance between them would be 17. The point I'm trying to make is that distances are always positive. So today, we're going to use the Pythagorean theorem to find the distance between 2 points. Your answer should always be positive. Okay? They should always be the absolute values because there's no such thing as negative distances. Okay? So now, let's talk on a coordinate plane, okay, and talk distances. If we looked at points like A and B, and I wanted to know the distance, in a coordinate plane, you could just count, how far they are. Now, the reason I picked A and B is because they are on the same y. They have the same y value, right? They're both up 2, up 2. So to count the distance is real easy. 1, 2, 3, 4, and I know my answer is always positive. So the distance from A to B is 4. Easy enough. If I wanted to do vertical ones, I would need ones that would be on the same x value, and I could count how far apart they are as well. The problem comes in, what if I wanted to know the distance from like B to E? A and B we could do easily. C and D we could do easily. But B to E, you can't really count how far that is. But what we can do is use the Pythagorean theorem to figure it out. Okay, so if we drew this into a right triangle, one of the legs would be 1, 2, 3, 4, 5, 6. So I could say 6 squared. And then this one I could say would be 1, 2 squared. Okay? And that would equal my missing side, which you don't have to call C. You can call it technically whatever letter you want. So now I have 36 plus 4 equals c squared. That is 40 equals c squared. I do the square root, I do the square root. And the square root of 40, we're going to round to the nearest tenth just because that's what we've been doing lately. That means that the distance from -2, 1 to 4, 3 is 6.3. Now when you're done, you always want to ask yourself, does it make sense? If you think about it, it's the hypotenuse. It has to be longer than the other two sides. My other sides were 6 and 2, okay? 6 and 2. So it does make sense that it would be bigger, 6.3.